Okay, so first homework of the year. Let's see if we can't knock out a couple of these questions together to help you out. Okay, so turning fractions to decimals, bar notation if needed. So first one, 83/5. This one's a little bit different because it's not a proper fraction. So when we divide this, it's still top in, bottom out, right? But this time, since it's improper, we know there's going to be a whole number part to this answer. So we say, how many times can 5 go into 8? That's 1. 1 times 5 is 5. And we subtract here. 8 minus 5 is 3. Bring the 3 down. 5 goes into 33. And this is why I put this math chart over here, because I saw some people are having trouble because they forgot their facts. So this could really help you out. So if you want to print one of these out or write one up, this will definitely help you with what we're working on. So 33, 5. So here's my 5s table, right? And I can just count 5, 10, 15, 20, 25, 30, and I just stop before I get to a number bigger than 33, just right here, which is 6. So 5 has to go into 33 6 times. 6 times 5, well, we stopped at 30, so this has to be 30 here. So subtract 3. Still have a number left over, so we had a decimal, and a 0. So 5 goes into 30 6 times. So it's the same as before. We say, is that repeating? Well, no, because even though it's the same answer, it's not the same number we're working with. This was 33. This was, wait, where did I go? Yeah, 30, right? 30. So different numbers. So even though you get the same answer, doesn't necessarily mean it's repeating. 6 times 5 is going to be 30 again. This time we have nothing left over. So 83/5 is just 16.6, and that is very terminating. Okay, there's that one. Not too bad. Let's put these together and then make them a little smaller so we can move them out of the way. All right, number 16, 3/7. I like this one because the 7s are interesting. You don't see them that often. So 3 on top, 7 on the bottom. So this is a proper fraction, so I know 7 can't go into 3, so I'm going to add a decimal and a 0. I'm going to foreshadow a little bit here. 7 goes into 30, so we're going to need our 7's times table here. Let me see if I have a highlighter. Highlight our 7's table. Okay. So how many times can 7 go into 30? Well, that is 4. 4 times 7 is 28. Subtract, we get 2, and we keep going. 7 into 20, it's not quite 21, so it's going to be 2. So it's 14. Subtract, we get 6. We keep going. So I told you this is going to repeat, but it's going to take a while to get there. So let's take a while to get there. 7 into 60, we go back again. 63 is too big. 56 just right. So that's 8. 7 times 8, I told you, is 56. Hopefully you remember that little story. This is 4. So keep on going. 7 into 40. Switch over here. It's going to be 5. And so 5 times 7 is 35. Subtract 5. We keep going. Hasn't repeated yet. 7 into 50. Oh, we haven't done that one yet. We keep going. That's a little bit past 7. So it's going to be 7 here. 7 times 7 is 49. That gives us 1. We keep going. How many times can 7 go into 10? That's just once. And 1 times 7 is 7, which leaves us with 3. So if we bring down another 0, we're going to get 30, and that is where we have come full circle. So 3/7 is all this, 0.428571. Now it's interesting about 7ths, and I can bring up a calculator here, and we can prove that 3/7 is the number we said, and we can see, oh, I forgot, let me put this on here. This is not just 0.428571. got ahead of myself. This is 0.428571 repeating. Ah, that's important. That was my bad. Almost caught myself. Okay, so 3/7 0.428571. Okay. If we take any other sevenths, like if we just say 1/7, okay, we get 142,857. Okay. So let's copy this over here somewhere. So I'm gonna actually delete all this hard work we just did. So 1/7 is 142,857. And what's interesting about that is that it's the same, whoops, I put that in the wrong marker. It's just going to delete on me. 140, no, still in the wrong marker. 142,857 is the same six numbers in the same order, just starting in a different place. You see that? So this one went 1 at the end, and then it started back up at 42857. And this one is 142,857. And all of your sevens have the same six numbers in the same order. They just start at a different place. Okay? And since all six numbers are different, this makes it really easy to fill in the rest. Like 1/7 is the smallest, so you pick the smallest of the six numbers and you start with that one. Now if we wanted 2/7, the second biggest number here is 2. The next number would be 8, followed by 5, 7, 1, 4. And you could go through, and once you know one of the answers, you can then write down all the sevens relatively easy, which I think is pretty neat. But it's always repeating, always the six places. So you never really get to see six decimal places either. So that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, to the millionths place. It doesn't get to the millionths place till it repeats. Pretty interesting stuff to me. Might not be for you, but your kids. You'll figure it out someday. All right. Then we got 2.42. This one's a little bit different. We wanted this one as a fraction, but it's 2.42, so it's not just going to be a fraction. It's going to be some sort of mixed number. So it's going to be 2 and something. And we talked about just reading decimals to make them fractions. So this is just 42 hundredths. If we were to read this number without saying point, we'd say 2 and 42 hundredths. Then it wants us to simplify it. So if we remember our divisibility rules, since both of these numbers are even, I know I can divide. And let's do this somewhere over here. It's 42 over 100. We can divide both of those numbers by 2 because they're even. 42 divided by 2 is 21. 100 divided by 2 is 50. Okay? So can we simplify that more? Well, I'm not sure because I'm in 7th grade. But I have my multiplication chart here, so I can look for, if I look for 21, the only place I see it is right here between 3 and 7, which means there's also another one over here. So what I look for now is 50 in either that row, or that column, I guess, or that row? And no, I don't see it, which means they don't share any factors, which means I can't simplify that anymore. So this is just going to be 2 and 21 over 50. That's a 5. 50. Getting worse. Okay. There's your answers. There's 3 of them. And I wanted to look at this one just because time eludes people. So Jake ran a marathon in 3 hours, 12 minutes. Write that as a decimal. Okay, so hours and minutes, separate units of time. So if we want to put it as a decimal, we either need to put this in minutes or hours. Since it wants a decimal, that means part of something. So it probably wants it, how many hours did he do this in? Okay, so we know 3 is the whole part, 3 whole hours it took. And then part of 1 hour just 12 minutes. So that's 12 over what? So how many minutes are in 1 hour? Which hopefully you know is 60. So now we could, because it wants a decimal, so we need to know what is 12/60 as a decimal. So you could either, and I'm not going to do this one for you, I'll let you do it. I want to have all the fun. You could either do the division like this, or 12 divided by 60, or you could recognize that this isn't as simplified as it could be. You could either work it out yourself, you could go back to your multiplication chart, and simplify 12/60ths, and then do that division instead. So it's an extra step, but less dividing. It's up to you. All right, I'll let you finish this up. Have a good night.